I made this video called Taking People Through the Model, and in it, I did this thing with prime numbers in a table, and I wanted to expand on that. I did a lot of work, and I went through the first 50 prime numbers. Some very interesting things emerged. I had some expectations too, and uh, the numbers did what they wanted to. They didn't necessarily comply with my expectations. You may remember from the previous video, taking people through the model, how I compared two tables. This top table is the prime numbers table, and this bottom table is the integers table. And you can see that I bring them up here so you could stop the video and take a look at how they're constructed if you have questions. You can see that they are both constructed the same way, and that therefore they can be compared, and you can actually derive the next prime number from the information that you see available to you in the integers table. So how I approached it this time was to try and make it more explanatory to just look at the table so as to understand what's going on. So when I developed the prime numbers, I did them one at a time and added them. I'll just scroll through this so you can stop and read the notes I've made if they make any sense. And see how I added these numbers as I went along. The table down below, the integers table, is where I put the locations and I color coded them. And I got this representation. I thought to begin with, when I was doing this, that down here in the integers table, I would have a representation under the one axis and above the two axis as it develops. That I would have these numbers develop here in this space, and that they would not get away from it. But I actually found something quite other than that. It's close, but it didn't. Okay, so I wanted to scroll through more of this so that anybody could just stop it and see what was going on. And plus I wanted to introduce the idea of where these red marks are coming from, in addition to, we've been using the orange ones to define the locations, but the red ones are also part of this entire calculation. They are related. They're reciprocals. Once we get away from using one and we start using the equivalent of one to evaluate to the next prime number, which, yeah, what you can do, see what I'm doing here is I'm trying to examine the characteristics of the prime numbers. I'm not really trying to discover the very next prime number. I'm trying to evaluate these prime numbers and see if there's anything to them. I'll scroll through some more of these just to give you can stop at any time. So anyway, down here in the integers table, I zoomed out so that I could show you what's going on with this distribution. You get this, and they do stay within underneath the one axis and then above the two axis, but they do something quite interesting. You get one of the numbers that you discover coming off of the 2 and the 3 axis diagonally, as we have been developing this, and alternating between them to discover the distribution here of the prime numbers in the integers table, which stay, but then they eventually exceed it. And this one hugs the new definition of what the equivalent of 1 is. You can see how much work this was to try and discover these things and how far out this goes. It gets easier when you discover, you do this enough and you find out how you do these things. But basically, this one is going out above the 1 axis. The cursor is trying to, and then gradually, and finding this and adhering to that new definition of what 1 is for the definition of the prime numbers. And the other one stays underneath the 1 axis and does something very interesting. Down here, you get the representation of a frequency, which, if you can follow it, is running through here, and it's just a wave taking a particular direction. You know, and what happens, of course, is they get separated. And this one is not caught up in having to be bound up in a wave form, but is only adhering to that. So those two different things that have something to do with how we understand prime numbers in this method, they get further and further apart. One of them is following the new meaning of 1, and the other is following a frequency, and the separation becomes more extreme with every iteration. Yeah, and the model that I was taking people through before, when I did the video called Taking People Through the Model, is really all about how these tables and the information that they represent has to do with the atom and with the construction of the universe, and how this model represents it. And so what you have with this separation is something like an explanation for the redshift within the model. That's really something. Yeah, so these two lines that we've been following are not necessarily like straight line representations. You know, even in the frequency, it breaks up a little bit. And the other line above that follows the new existence of 1 as we develop the prime numbers, that they are subject to how the electron shells develop, like the S and P and D shells, that they have an impact on this too. There's so much more I really wanted to say about all this, but I'm already getting to the point where I can tell it's just going to be overwhelming. And I wanted only to express the very beginnings of these things that I'd found, for people who are curious, like I am, about what's going on with what you can do with this kind of geometrical examination of math like this. It's not formulaic. I'm not really a good formula type person. I see things in my head, shapes and images and things, and I try and figure out how to approximate them, create them with math. And I use these tables to help me visualize how that can be done. And it does help.